Hi friends, welcome to my channel Mathematics Idea. This video is also available in Hindi. यह वीडियो हिंदी में भी उपलब्ध है. If you are first time viewing this channel, I will suggest you to go through the introduction video first to understand the presentation structure of the course content. We are at the class of matrices now. Okay, today is detailed explanation class 4 for matrices. This class is based on the operations of the matrices, right? Now, what we had done, operations of the matrices, we had divided it into two parts. One, between two matrices, that means taking two matrices and doing operations between them, such as addition, subtraction and multiplication. Okay, addition, subtraction and multiplication. This is covered in one of our previous detailed explanation class. Now, we had moved to this branch of the operation, which is within the matrix. One matrix is taken. Within that, what are all the operations can be performed? Okay, what are all the operations can be performed? Those are trace, scalar multiplication, transpose, conjugate, row operations, determinant, adjoint and inverse, right? So these are the 8 operations which are possible within the matrices. Now, in these 8 operations, in our previous detailed explanation class, we had completed first 5 operations, that is trace, scalar multiplication, transpose, conjugate and row operations. So what we had done in previous class? In previous class, we had completed this and this. Okay, that is happened in our previous detailed explanation class. In this detailed explanation class, we will go through these 3 operations. Okay, we will go through determinants, we will go through adjoint, we will go through inverse. Okay, what we will do in this class? We will go through determinants, adjoint and inverse, right? Now let's get started. Now, before understanding determinants, we need to understand 2 terms, which is minor and cofactor. Okay, which is minor and cofactor. Now let us see what a minor and cofactors are. This is a matrix A. Okay, so we had discussed in our introduction class that any element in a matrix can be represented in the form of Aij, where A is its row number and J is column number. What we had done here, we had taken a matrix A of order 2 by 2, 2 rows and 2 columns, right? So there will be n by n minors possible in this. Okay, how many elements are there? N by n elements, right? It is 2 by 2, so there are 4 elements in this: A11, A12, A21 and A22. There are 4 elements in this matrices. So there is a possibility that there are 4 minors also for this matrix, right? So number of minors in this matrix is equal to the number of elements. Okay, minor of an element Aij we represent with Mij. Okay, Aij minor we will represent with Mij. Like for A11 we will write it as M11. For A12 we will write it as M12. Like that, A21 we will write it as M21, and for A22 we will write it as M22, right? So these will be the minors of the matrix. Okay. Now, what will be the value of M11, M12, M21 and M22? To find the value of minors, first let's understand how minor is represented. Minor is represented by Mij. Once a minor is represented by Mij, we need to strike out ith row and jth column in that matrix. Okay, suppose I have to find M11. So what is my row number? My row number is 1 and column number is 1. So I have to strike my row number 1, sorry, this is column number, my row number 1, this one, and my column number 1, this one. Okay, so my row number 1 and column number 1 I have to strike out. What we are left with? A22, right? So my minor for this will be A22. Are you getting it? Okay, let's move on to other minor. So how many minors are possible? I told there are 4 minors, as there are 4 elements. A11, A12, A21, A22, 4 elements are there. So minors are also 4 possible. So for my M22, M12, next minor. For M12, what will be my minor? I am having first row, second column. First row I have to cross it out. Okay, first row crossed out, and second column this element crossed out, this element crossed out. So my minor M12 will become A12. Sorry, A21, not A12. It's A21. So once A11, A12 and A22 are crossed out because of this first row and second column, so we are left with A21 over here, right? So my minor M12 will become A21. Like that. What will be my minor M21? M21, I have to strike out second row and first column. So what will be my second row and first column? This is my second row. I will strike out my second row now, and first column. This is there and this is my first column, right? So what I had left with? A12. So my M21 minor will be A12. Okay, there will be 4 minor, so fourth minor will be M22. So M22, second row, second column. This is my second row, so I will strike second row elements, and second column I will strike this element. I am left with now A11. So my M22 will be A11. Okay, so this is how we have to find the minors. Okay, this example of 2 by 2 is basically for you to understand how we need to strike the column and row. Okay, how we need to strike the column and row to find the minors. Next example we will go with 3 by 3, where we will understand exactly how to calculate the minors. Okay, so for M22 this is how, for A2 by 2, this is how we have to find the minors. So for a matrix A, for A11, A12, A21, A22, minus M11 will be A22, M12 will be A21, and M21 will be A12, and M22 will be A11. I had taken an example of 1, 2, 3, 4. This is one of the matrices. In this matrix, what will be my M11? A22. A22 is this element, so it will be 4. Right? Now M12 is for A12 element. So for A12 element, my M12 will be 3. So it is A21 is 3. For M21, it is A12 element. So it will be 2. And for M22 element is A11, which is 1. Okay, this is how we need to find minor. Okay, right. Now once we found the minor, how to find the cofactors? Cofactors and minors, the difference is with its negation sign. Now how to put this negation sign? What we do, we will multiply our minor with -1 to the power of I plus j. We will multiply our minor with -1 to the power of I plus j, where I is number of row and j is number of column. Then we will come up with cofactor of that element, that is Cij. So cofactor is represented by Cij, and for element Aij, cofactor will be Cij, which will be equal to -1 to the power of I plus j Mij. Okay. Now for the same matrix, let us identify what will be our cofactors. So I will replace these all m's with C now. C11, C12, C21, C22. Okay. Now minor was A22. So -1 to the power of, it is 1 1. So we have to put 1 plus 1. Right? Here also it is 1 2. So -1 to the power of 1 plus 2. 2 1, -1 to the power of 1 plus 2. And C22, -1 to the power of 2 plus 2. Right? Now -1 to the power of 1 plus 1, positive. So it will be A22, which is 4. -1 to the power of A21. -1 to the power of 1 plus 2, which is negative. 1 plus 2 will be 3, it will be negative. So minus A21. So minus A21 will be -3. So -3 will be the cofactor C12. C21, -1 to the power of 1 plus 2, which will be negative. So minus A12, it will be -2 again. And our C22, which is -1 to the power of 2 plus 2, it is positive. So it will be 1. Okay. So wherever we are seeing that there are odd positives, odd power for -1, wherever there is a odd power for -1, there we are getting a negation of minor. Right? There we will get negation of minor, because -1 to the power of odd will be negative. Negative into the minor will be the cofactor in that case in which I plus j is odd. Whenever I plus j is a positive, then -1 to the power of even, I plus j, when I plus j is even, then -1 to the power of even will become positive. Okay, -1 to the power of even will become positive. In that case, cofactor will be equal to minor. Okay, so what is our conclusion now? If I plus j is even, then minor is equal to cofactor. Now when I plus j is odd, then minus Mij be our cofactor. Understood? So these are what minors and cofactor for a matrix, right? What we had done here, we had done our 2 by 2 matrix. We had taken 2 by 2 matrix and we had derived that how minors and cofactors are calculated for a 2 by 2 matrix, right? Now just have a look on the notes. After that we will take one 3 by 3 matrix and we will see how minors and cofactors are calculated. Okay. Now what we have done now, we have taken a 3 by 3 matrix. So how many elements are there? There are 9 elements, right? 9 elements are there. So how many minors will be possible? 9. Cofactors also 9. 9 cofactors. Okay. So each cofactor is derived by minor as -1 to the power of I plus j mij. Right? This is what we had discussed till now. For a 3 by 3 matrix, how to find now minor M11? My target is now to find minor M11. For minor M11, what is our first step? First step is our row number is 1, column number is 1, right? Row number 1, column number 1. Strike out row number 1, column number 1. What we had left with? A22, A23, A32, A33. Just write it down. A22, A23, A32 and A33. Right? These are the elements which were left out. Okay. With these 4 elements, we have to find now minor. Okay, these elements are not used of first row and first column. We had striked that out, right? This is what our first step is. Now, after that we had identified that what are all elements or numbers will be used for finding the minor. These are the elements which will be used for finding the minor. Now, what will be the minor value? For that, you just remember this arrow. Arrow is left to right, down first. After that, left to right, up. Okay? What I told? First arrow will be left to right, down. And second arrow will be left to right, up. Okay? By doing that, we will find the minor of M11. Left to right arrow, we have to multiply these 2 elements at the end of the arrows. So A22 and A33 were multiplied. So my M11 will be A22 into A33 minus A32 into A23. Left to right, up. So A32 into A23. So it will be A32 into A23. Okay. So this will be my minor M11. What we have to do? Left to right, down. We have to multiply these 2 elements minus left to right, up. We have to multiply these 2 elements. Same thing we will follow for all the minors. Okay, so this is for M11. For M12, what we will do? We will take second column and first row out. Okay, M12 means first row and second column. So first row is out, second column is out. So what we are left with? We are left with A21, A23, A31 and A33. So my minor for A12 will be M12, and we will be having A21, A23, A31, A33. Right? Now, left to right, down, A21 into A33. So, A21 into A33 minus left to right, up. So, A31, A23. A31, A23. Okay, so this will be minor M12. Similarly, we will do for M13. So, M13, first row and third column. Okay, first row and third column is taken out. So, it will be A21 into A32 minus A31 into A22. Right? Like that, for M21, we have to take second row and first column. So, we will be left with A12, A33, A32 and A13. This one is strike off, this one is strike off. So, we will be left with A12, A13, A32 and A33. So, it will be A12 into A33 minus A32 into A13. Right? So, this will be my M21, sorry. So, M22, second row, second column. So, it will be A11 into A33 minus A31 into A13. M23 will be second row and third column elements will be striked off. So, we will be left with A11 into A32 minus A31 into A12. Okay. Now, M31, third row, first column strike off. So, A12 into A23 minus A13 into A22. Right. What will be my M32? Third row, second column strike off. A11, A23 minus A21, A13. M33 will be third row, third column strike off. A11, A22 minus A21, A12. Right? So, this is how we will find all our 9 minors. Okay, understood? So, this is how we will find our 9 minors. Now, let's take the example of this matrix, which is 3 by 3, 1, 2, 3, 4, 5, 6, 7, 8 and 9. And we will find what will be our M11. So, M11 will be 5 into 9, 45 minus 8 into 6, 48. So, 45 minus 48 is minus 3. So, my M11 will be minus 3. What will be my M12? A21 into A33. So, A21 is 4 into A21 is 4 and A33 is 9. So, 4 9s are 36 and A31 and A23, which is 7 and 6. So, 36 minus 42. So, it will be minus 6. So, similarly, we will write it for M13. M13 will be 32 minus 35, which is minus 3. Right? 32 minus 35. 8 4s are 32, 7 5s are 35. Now, M21. M21 will be 9 2s are 18, 8 3s are 24. So, 18 minus 24 minus 6 again. M22. M22 second row and second column taken out. So, 9 1s are 9, 7 3s are 21. So, 9 minus 21, how much it is? 12. So, it is minus 12. M22. Now what will be my M23? M23 will be second row and third. Second row and third column we need to strike off. So 8 minus 14. It will be again minus 6. Right? What will be my M31? M31 means third row and first column. 6 to the 12. 12 minus 15 minus 3. So it will be minus 3. What will be my M32? M32 will be third row and second column strike off. 6 minus 12 minus 6. And after that M33 third row and third column strike off. So it will be 5 minus 8, which is minus 3. Right? We will check it again. M11 first row first column gone. 5 9 ja 45, 6 8 ja 48. 45 minus 48 minus 3. M12 second row first row second column. 9 4 ja 36. 36 minus 42. 36 minus 42 is minus 6. M13 is first row third column strike off. 8 4 is 32. 32 minus 35 minus 3. Right? So M11, M12, M13 is checked. Now let's come for M21. Second row first column element is 4. For second row and first column need to be strike off. So 9 2 is 18 and 8 3 is 24. So 18 minus 24 minus 6. M22. M22 is 5 over here. That means second row and second column need to be taken out. So second row second column strike out. Then 9 1 is 9. 7 3 is 21. So 9 minus 21 is 12. Minus 12. So it is minus 12. Now M23. M23 will be second row and second row and third column. Right? So second row and third column means second row is strike off and third column is strike off. So 8 1 is 8 and 7 2 is 14. So 8 minus 14 minus 6. Right? Now M31. M31 means third row and first column strike out. 2 6 is 12. 3 5 is 15. 12 minus 15 minus 3. M32. Third row second column strike off. 6 1 is 6. 4 3 is 12. 6 minus 12 minus 6. M33. Third row third column strike off. So 5 1 is 5. 4 2 is 8. So 5 minus 8 minus 3. Right? So we found 9 minus over here. Correct. Now what will be my cofactors? Cofactors is nothing but C11, C12, C13 like that till C33. Okay. Now to find the cofactor, what we have to do? Minus 1 to the power I plus j of mij. Okay. Where I and j are row and column numbers. So here row and column numbers are 1 and 1. So minus 1 to the power of 1 plus 1. So 1 plus 1 is even. So minus 1 to the power of even, it will be positive. So minor will be equal to cofactor here. So it will be minus 3. Are you getting it? Right? Now M12, 1 plus 2, odd. Minus 1 to the power of odd, negative. So there will be a negation sign to minor M12. C12 will become 6. Like that. For M13, power is even. Minor will be equal to cofactor. 2 1, power is odd. Negation of minor. 6 minus 6 will become 6. C22, even power. Minor will be equal to cofactor. Minus 12. M23, 2 3. Even. Okay, 2 plus 3 is odd. Odd means negation of the minor. It will be 6. 3 1. Even. Cofactor will be equal to minor. Minus 3. 3 2. Odd. Cofactor will be equal to negation of minor. 6. M33. 3 3 means even. Now minus 3, it will be minus 3. Our cofactor will be equal to our minor. Right? It is. Just make it good. Minus 3. Right? So this will be my minors and cofactors for this 3 by 3 matrix. Right? Now, for cofactors, we had seen that minus 1 to the power of I plus j will define the sign, right? So, sign matrix for the cofactor will be written as plus minus plus minus plus minus plus minus plus. Okay? Adjacent signs will always be opposite. Adjacent sign will always be opposite. So you start with 1 1. In 1 1, 1 plus 1 is even. So minus 1 to the power of even, it will be positive number. So first will be positive. So start from plus. After that it will be minus, minus, because adjacent signs cannot be same. So minus, minus. After that you take adjacent sign as positive, because after minus plus will come. Like that you can derive the matrix. Okay, how big the matrix is, you can derive these signs. So wherever plus are coming, wherever we see there are positive signs, in these places minor will be equal to cofactor, and wherever there are wherever these negative signs are there, at those places there will be negation sign included to minor to arrive the cofactor. Okay, so what we had done till now, we had understood how to find the minors and cofactors for 2 by 2 matrix and a 3 by 3 matrix. Okay, just have a look on the notes. Next we will go through our determinants. Right. Let's move on to find determinants. We understood how we find minors and cofactors. Okay. Now move on how we will find determinants. Let's take our 2 by 2 matrix first. Next we will go for our 3 by 3 matrix. Okay. In our 2 by 2 matrix, just how we found minor, we will get determinant. Okay. So what is a determinant? Determinant is a number which is derived from a matrix. It is a scalar number. It will be one number which will be derived from a matrix, right? And that determinant will be represented by delta. Okay, this is the sign to show the determinant. So determinant of this A will be delta, which is equal to A11 into A22 minus A21 into A12. I will write it nicely. It is kicking off this partition. So delta equal to A11 into A12 A11 into A22 minus A12 into A21, right? A11 into A22, left to right down and left to right up arrow. Okay, so this is what the determinant for this 2 by 2 matrix. Now let's find the determinant for this, which is our example. So for this, our determinant delta will be 1 into 4. A11 is 1, A22 is 4. So 1 into 4 minus 2 into 3, which will be 4 minus 6, which is equal to minus 2. Okay, which is equal to minus 2. Right? Delta is the symbol for determinant. Matrix A is written with this box bracket while finding the determinant. Okay, for a specific matrix like A, we will specify matrix between the two straight lines like this. This means we are finding determinant for matrix A. Okay, so delta is the symbol and this is the representation for the specific matrix, determinant of matrix A. Understood? Okay. Now let's move on to 3 by 3 matrix. Right? Now in my 3 by 3 matrix, this will be, my matrix will be A11, A12, A13, A23, A31, A32 and A33, right? So this will be my matrix. Our sample problem, we will take it as 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, we will take this as our sample problem. Now for a 3 by 3 matrix, how to find the determinant? Okay, for 2 by 2 matrix, what we had done for determinant? We had used the approach how we found the minor for M11. Similarly we had done. Okay, so it is as similar as finding the what we had done the operation for finding the minor, right? It is left to right down and left to right up arrow, do the product of the elements and subtract both of them, right? Now for 3 by 3 matrix, okay, for 3 by 3 matrix, we have to expand the determinant through any of the rows or any of the columns. So what we have to do? We have to first fix the row or column. Okay, what we have to do? We have to fix the row or column. Once we are fixing the row, that means I is fixed. Okay, I is fixed. Once we are fixing the column, that means J is fixed. Okay, we can expand through any of the row and any of the column. We will get the same value of the determinant. Okay, now how to expand it? Let me take one example, that let's take this row 1. Okay, let's take this row 1 and expand through entire row, right? So what will be my determinant for this A matrix? It will be determinant equal to A11 into C11 plus A12 into C12 plus A13 into C13. Okay, so my determinant along this row, first row, will be A11 C11, A12 C12, A13 C13. Sum of all three will give me the determinant. Are you getting it? If I will expand through any of the other rows, how it will be? If I am expanding through second row, then it will be A21 C21 plus A22 C22 plus A23 C23. Okay, if I am doing for third, then it will be A31 C31, A32 C32, A33 and C33, right? So this is how the determinant for a matrix of 3 by 3 will be found. Okay, are you getting it? So let's find what will be my determinant for this. So what is my A11? Let's take this example of 1, 2, 3, 4, 5, 6, 7, 8, 9. So what is my A11? A11 is 1. What is my C11? Minus 3. So it will be minus 3. Plus, what is A12? A12 is 2 and my C12 is 6. So 2 into 6 plus, what is my A13? A13 is 3 and what is my C13? C13 is minus 3. So it is minus 3. Okay, so 1 into minus 3, 2 into 6, 3 into minus 3. What will be the result? Minus 3, minus 9, minus 12. Minus 12 and plus 12, it will be 0. So my determinant for this matrix is 0. You try expanding through any other rows or through columns also. So suppose I am expanding through second column. Then my determinant will be A12, C12 plus A22, C22 plus A23, C23. Okay. So it will be my determinant if I will expand through second column. So you can expand through any of the rows and any of the columns, you will get the same value of the determinant. Okay. Right. Now what we will do, we will take another matrix and we will practice how to find the determinant of that matrix. Okay, we will practice how to find the determinant of that matrix. Right. And for the further properties of the determinants and all, we are planned another one detailed explanation class. Okay, determinants is a very big topic and it holds a very good weightage in your examinations. So what we will do, we will explain all the determinant properties and all its operations in some other detailed explanation class. Okay, it is some of the follow-up class. Okay. Okay, right. Now you go through your notes. Right. What we have done is, we have taken another matrix 3 by 3, A matrix, for which the elements are 0, 2, 6, 1, 5, 0, 3, 7, 1. What we will do, we will expand it through row 3. We can expand it through any row and any column, right? We will expand it through row 3. So determinant of A del, which will be equal to, what will be the expansion through row 3? It will be A31 C31 plus A32 C32 plus A33 C33, right? So it will be 3 into, which is A31. For A31, for what will be the minus 1 to the power of I plus j? It is 3 plus 1, right? So 3 plus 1 means it's a even number, so my cofactor will be positive. So what will be my cofactor here? It will be 0 into 2 minus 5 into 6. This will be my cofactor. Plus, next it is 3, 2. For 3, 2, I minus 1 to the power of 3 plus 2. 3 plus 2 is 5, which is odd. So there will be a negative cofactor. So negative minor of the a negative minor is used to find the cofactor, right? Minus 1 to the power of I plus j mij. Okay, so negative minor is used. So minor for this will be, how to find it? Strike out second column and third row. 0 into 0, so it will be 7 into 7 will be my A32 and it will be 0 into 0 minus 6 into 1. Okay, so this will be my second element for finding the determinant. What will be my last element is A33, which is 1, and what will be the minor of that? It will be 5 into 0 and 2 into 1. So 5 into 0 minus 2 into 1. Here cofactor will be positive because it is 3, 3, 3 plus 3 is even, right? So this will be my determinant. So it will be 3 into minus 30 minus 7 minus 6 plus 1 into minus 2. Okay, so it is minus 90, right? 330 is a 90 plus 42 minus 2, which is equal to minus 50. Okay, So minus 50 will be the determinant of this matrix. Okay, so this completes the determinant section over here. Now let's move on to our adjoint. Okay. Now let's move on to our adjoint portion. Now what is the adjoint? Adjoint is a matrix, right? So in earlier section what we had discussed? We had discussed determinant. What is a determinant? Determinant is a scalar value. It's a value for a matrix, just a number. Okay, but adjoint is a matrix. So if suppose we are taking a 3 by 3 matrix A, which is A11, A12, A13, A21, A22, A23 and A31, A32, A33. Okay, if this is my A matrix, then adjoint of A will be given as its cofactors transpose. Okay, we will do the cofactors, we will find the cofactors which we had discussed earlier in our this lecture, and we will transpose it. Okay, what we will do? We will transpose it. Transpose operation go through our earlier detailed explanation class, right? So it is cofactors transpose. Okay, we had took the sample problem here, which is A026150371. Okay, this is our matrix A. Now let's find what will be its C11, C12, C13 for this. So for C11, first row and first column strike off. So it will be 5 minus 7 into 0. So it will be 5. C12, first row and second column strike off. So it will be 1 into 1 minus 3 into 0. So it will be 1. Here 1 and 2, 1 plus 2 is odd. So there will be a negative sign over here. Okay, minus 1 to the power of I plus j mij. Okay, right. What is C13 now? C13, first row and third column. 7 minus 15. 7 minus 15 is minus 8. Right? 7 minus 15 is minus 8. What will be my C21, C22 and C23? So C21 will be second row first column. So 2 minus 42 minus 40, and 21 is an odd 2 plus 1. So that's why there will be negation to this minor. It will be 40, right? Now C22. C22 will be a positive minor. It will be 1 into 0 minus 18. So it will be minus 18. What is my C23? C23, second row and third column, you have to strike off. So it will be 7 into 0 minus 6. So it is minus 6, and there will be a negation of minor in this. So it will be plus 6, because 2 plus 3 is odd. So that's why we have to negate the minor. So 31, C32 and C33. Now how to find the cofactors? This 31, third row and first column we have to strike off. 2 into 0, 0, 5 into 6, 30. So it will be 0 minus 30, minus 30, and C31 is same as M31. Now C32 will be minus M32. So minus M32. What will be M32 for this? 0, 0, 1 into 6, minus 6. So minus of minus 6, it will be 6, right? So this cofactor is negation of its minor. Here C33. So for 33, it's minus 1 to the power of 3 plus 3, which is 6. So it's a positive. It is minus 5 into 0 minus 2. So it is minus 2. Okay, are you getting it? Now we will take the adjoint of this matrix A. Then adjoint of matrix A will be C11 is 5, C12 minus 1, C13 minus 8, C21 40, C22 minus 18, C23 6, C31 minus 30, C32 6 and C33 minus 2, and whole transpose of this. So once we perform transpose, rows will become column and column will become rows. So it will be 5, 40, minus 30, minus 1, minus 8, minus 18, 6, 6, minus 2. Right? So this will be my adjoint for this matrix. Okay? So this is how we need to find the adjoint. So I conclude, for the adjoint, we need to first find the cofactors. Once we found the cofactors, after that we need to do the transpose, and that matrix will be our adjoint matrix. Right? Now let's move on to inverse. Right? Let's discuss inverse. Now you might have aware for the inverse of the numbers. Like suppose a number is 2, then its inverse is 1 by 2. So what is inverse? Multiplicative inverse is 1 by 2. Okay. So what is a multiplicative inverse? Multiplicative inverse of a number is such a number such that if the product of multiplicative inverse to the number is 1. Okay, product of multiplicative inverse and the number is 1. Okay, in similar way, in a matrix, if the product of the two matrix will give identity matrix. Okay, we will discuss in detail what an identity matrix is in our type of the matrix, but right now you just think that identity matrix is equivalent to 1 in our numbers. Okay, in a matrix, identity matrix is just equal to 1. Okay, so if the product of the two matrix is an identity matrix, then these two matrix are inverse of each other. Like A and B, product of A and B will give an identity matrix, then A is inverse of B or B is the inverse of A. Right? Okay. So this is what an inverse is. Now how to find the inverse? To find the inverse, we will use one property of an adjoint. The property of the adjoint is matrix A into adjoint of A is equal to that of A into identity matrix. Okay, this is the property which we use to find the inverse. So what we do, we will multiply A inverse on both the sides. Okay, we will multiply A inverse on both the sides, and this determinant of A we will get into our left hand side. Then we will get as A inverse is equal to 1 by that A into adjoint of A. Okay, 1 by that A into adjoint of A. This is how we will find the inverse of a matrix. If A is a matrix, then inverse of that matrix is given by A inverse, which is 1 by det A into adjoint of A. Okay. Now, we had taken this matrix as our example matrix. 0, 2, 6, 1, 5, 0, 3, 7, 1. Det A is minus 50 for that, and adjoint A is this matrix. So what will be my A inverse for this? The A inverse for this A matrix is minus 1 by 50, because det is 50, adjoint is 5, 40, minus 30, minus 1, minus 8, minus 18, 6, 6, minus 2. Okay, this is my inverse of the matrix A. Are you getting it? Right. So this inverse of the matrix A is 1 by det A into adjoint A. Now how I will get the entire matrix is just it's a scalar multiplication. Scalar is minus 1 by 50. You multiply with each and every element in this. So we have discussed this in our scalar multiplication, right? So we do that, then we will get A inverse matrix. Okay, so I repeat, A inverse is found by this property of the adjoint. If you want to see that how this property is arrived, just go through the notes which is displayed just after this section. Okay, now from this we will come that A inverse is equal to 1 by det A into adjoint A. This is done by multiplying A inverse on both the sides, and after that det A is transferred from RHS to LHS. Now what we had done, we had took one example matrix, and for that we had arrived to its inverse. Okay, now just go through our notes. Now in next section we will discuss what will be the properties of inverse, right? Go through our notes. Yeah. Now we will see our three main properties. Okay, there are various properties. Okay, these are the three main properties, and whenever we will get the need of these properties, we will discuss in that problem itself, which will be in our workshop sessions. Okay, just I want to make you aware of these three, which are the main properties for the inverse. Okay, so first property is, if you take two matrices A and B, do the product and inverse, AB inverse is equal to B inverse into A inverse. Okay, this is the first property. Same thing can be mapped for transpose also. If suppose AB transpose is written, then it is B transpose into A transpose. This is the property for transpose. Same product can be mapped for adjoint also. Adjoint AB is equal to adjoint of B into adjoint of A, right? So this is very important property, that's why I had noted down it here. So AB inverse is equal to B inverse into A inverse. Same thing can be mapped to the transpose and adjoint as well. AB transpose is equal to B transpose into A transpose. Adjoint AB is equal to adjoint B into adjoint A. Now next property is, A transpose inverse is equal to A inverse transpose. Okay, A transpose inverse is equal to A inverse transpose. Third property is, matrix A to the power K, after that you do inverse, or you do inverse of matrix A and after that multiply it for k times or give the power k, both will be same. Okay. Now this completes our today's detailed explanation class. So what we had done in this class, we had completed first determinants. For finding the determinants, we had approached it through minors and cofactors, right? So determinants we had found by using minors and cofactors. By using these cofactors, we had found adjoint as well. After finding the adjoint, we found inverse, right? So this is what the whole intent of our today's class was, right? For the next classes, please stay connected. Okay, thank you.